All right, something to understand here. This is an older truck with just a needle, right? When you get into the newer systems that are electronic and computerized and multiplexed, okay, there's a lot that can go wrong. And if I can confirm that the computerized system has not failed, if I can confirm that first, I'm going to be a lot happier in the long run, because that's going to take the whole system of computers and multiplexing and CAN bus and J1939 and all that stuff. It's going to take it out of the equation. Okay? Idle shutdown. Okay, so something to consider here. Mechanics want to go to the part. There's nothing wrong with that if it's mechanical. If it's electrical, the worst thing you can do is go to the part, because parts only fail 20% of the time. Wiring fails 80% of the time. And if it's a computer, the computer fails less than 1% of the time unless it's been miswired, which now makes it a wiring problem, and it falls into the 80% rule. So your best results will come from assuming that it's going to be wiring before you assume it's going to be anything else.
Okay, I got a 2-pin connector here. Okay. One's positive, one's negative, because this sender actually is using voltage, and because it's a variable resistor, it's going to act to change the current in the circuit, and it's going to create a voltage drop, and it's going to do all those things that you need to understand. And when the resistance of this sender changes, the current flow changes in the circuit, the voltage across the gauge changes, and the gauge needle moves. Okay, so this is really nothing more than a basic speed control circuit. And if you can steal yourself a connector off a wreck or something, if you can get yourself a connector off of an old fuel level sender, you might want to keep it handy. Okay, so there it is. All I did was just hook this in, and now what I've got is I've got a simulated fuel level sender attached to my meter and attached to the truck system. First of all, show you what I'm doing here. This is just a variable resistor. It's a pedal out of an old machine that was a foot pedal. That's a rheostat. I've added some resistance here at 33 ohms because the bottom end of this is 33 ohms, or I should say the top end. The top end of the fuel level sender is 33 ohms here. Here, I'll show you. 33 ohms on full, 240 ohms on empty. Alright, so it goes 240 to 33. Alright, well right now this is what you should see is the fuel level sender start to move. Okay, so I'm testing the fuel level sender system, and I'm pushing down, pushing down, pushing down, pushing down. The resistance is dropping, 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 dropping.
Alright, what I'm going to do is I'm going to use the Load Pro leads to read voltage. That'll be the voltage coming to the fuel level sender. As a reminder, resistance checks and ohming these things out is very, very, very painful. You don't want to do that if you can avoid it. So I'll stick these leads in, use the steady pin tips, which work really well. And I'm reading full system voltage coming out of the system, out of the gauge, out of all that. And when I load the circuit, notice that the voltage drops, and at the same time that I load the circuit, the gauge sweeps. So I'm actually using these leads. As a substitute fuel level sender. And I simply read voltage, push button, and I can determine whether or not it's working from here back into the system.
Listen, this gauge has a resistor. The fuel level sender has a resistor. And what happens is, as the resistance of the sender changes, the voltage drops in the system change, and this is effectively a motor which is then going to respond according to the change in resistance here because of the change in current through the circuit. So a certain amount of current will cause a certain amount of deflection of the needle. Now notice right now, notice that I have an open circuit. Well, with an open circuit to the sender, the gauge is showing less than empty. In other words, it's pegged out on the bottom. That's an open circuit according to the way that this system's built. If I then short it short it in the harness, for example, or short it at the sender, notice that it goes to full, and it goes to full deflection and it won't move. So if the complaint is never leaves below empty, assume it's probably an open. If the problem is that it always stays full and never changes, assume it's a short. Okay? Well, here's what's interesting. If you have a short and then you unplug the sender and it goes to an open, that means there's an open in the harness, which is good, and it means the short is in the sender, which is bad. So you isolate between the sender and the system by unplugging the sender and watching what happens. Okay? So open circuit, short circuit, unplug the sender. Open means that you have a good harness. If you had unplugged this and it had stayed full, it would have meant that the short is in the harness. Okay? That's basic diagnostics. Now, one more thing. Every one of these gauges has a certain amount of resistance required at the sender to read a certain thing. So what I've got here is I've got these resistors that I put together according to the chart in the manual, and each of these resistors here, each of these resistors is going to give me a certain reading. This one will give me empty, this will give me full, this gives me 3/4, half, and 1/4. So let's start with empty. Okay, empty is 240 ohms according to the chart. So if I put in the 240, notice the gauge goes to empty. Okay, if I then put in the 1/4, which is about 150 ohms, notice that the gauge goes to 1/4. If I put in 100, I get a half. And if I put in 60, I get 3/4. And last but not least, if I put in 33, I get full. The importance of doing the test this way somehow is that you're getting a calibrated answer that isn't just watching the needle move. You're forcing the system to work according to the specifications that it was built to. So that means you can make a much more intelligent decision about whether or not the system is working properly. Remember, the sender is just a very small part of the whole thing. The majority of it's wiring, and the wiring is the most likely thing to fail. Now, another thing I've done is simply taken a rheostat that I've had in my junk pile, and I can actually make the gauge work and watch the gauge move.